3.7 inverse function theorem for derivatives. So we want to find f inverse prime of a value. Okay. A function's inverse, we want to know the slope of a function's inverse. Okay. So there's a relationship between a function and its inverse that we know from pre-calculus. Actually, quite a few relationships. One of them is that if I were to draw the function f that has an inverse, maybe something like that, then to draw its inverse, I should reflect the graph of the original function f about the line y equals x. So if that's f, then f inverse should look something like like that. Okay? That's good enough. So just like there's relationships that exist between a function and its inverse, there are also relationships then between the derivatives of the inverse and an original. So let's pick a location here. We'll call this A right here. And so then the function value, height here, is of course f of a. Okay, so a comma f of a is sitting right there. And if I draw a tangent line there, it looks something like this. That's reasonable. So again, the goal is to find this. But to do that, I'm going to construct this picture and try to make it believable. There's a certain relationship between the derivative of the inverse at a location and the derivative of the original function at the same location. So first of all, f prime at a we have here, right, should be slope of the red. Slope of red tangent. All right. Every point on the inverse function can be mapped directly from the original by constructing a line perpendicular to the y equals x line and containing the point on the original function across here. A line that's perpendicular. You would have a corresponding point on the inverse, which would be the exact flip, the exact switch of the coordinates. So just as this point is a f of a, this point is f of a comma a. Okay? So down here on the x-axis is the value f of a, and over here on the y-axis is the value a. Okay? So this distance here to a is the same as this distance here to a, and this distance here to f of a is the same as the one here, f of a. The only difference is the order in which you write the points. This is a f of a, and this is f of a comma a. All right, just write that here. That's that point. And the one over here is the exact reverse of those coordinates, looking something like that. Okay? That's that point there. So I can construct a tangent to f inverse at f of a, be careful, that's not what we're doing right here. Right? We'll get to this in a second. But I can construct a tangent line here something like that. Okay. And the notation for that would be f inverse, I'm on the inverse function. I'm not just on that function, I am thinking about its derivative because I have a tangent line there. But where? At f of a, not at a. Right? It's happening at f of a for the inverse function's derivative. Right? The slope of inverse function at f of a should equal slope of green tangent.